Hello and welcome back to Math and Tea, the show where we talk math and drink tea. I'm your host, Professor Joseph Van de Hei. Besides teaching, one of the important roles that academic mathematicians, such as myself, happen to perform is research. And research involves writing and communicating our results to other mathematicians. But we really don't talk that much about how to write a paper. I mean, out of all of the courses I took as a grad student, one of them covered how to write a paper. So I thought I'd record a couple videos that talk a bit about the procedures that go into writing a math paper. Let's get started. For this episode, I want to discuss titles, abstracts, and introductions, essentially the front matter. Before we do that, we should discuss the law of diminishing reading returns. By this I mean that most anyone who encounters your paper in any way, shape, or form is going to read your title. A portion of the people who read the title will then read the abstract. A portion of the people who read the abstract will read the introduction, and then a smaller portion of that will read the rest of your paper. This makes academic writing a lot different from, say, fiction writing. In fiction, the hope is to have every reader who starts a story make it through all the way to the end, but this is not the case in your typical research paper. People just don't have the time to read through all the proofs of every paper that ever catches their eye. Instead, your goal is to be as informative as you can for the readers who do not read any farther. Let's start by talking about titles. It may seem silly to spend so much time talking about titles, but remember, there is no aspect of your paper that people will read more than the title itself, and there's a small yet fine art to writing a good title. Let's start with the goals of a title. The primary goal of a title is to be a concise description of the central topic of your paper. The secondary goal of a title is to make your paper sound interesting. I say that this is a secondary goal because most of the people who read your paper will read it because of the topic it covers, not because the title was particularly clever or interesting. Let's dig in a bit more onto each of these points. First of all, conciseness. You should use as few words as possible. I recommend no more than a dozen, although there are many exceptions out there. Titles are rarely complete sentences, but should still follow basic English grammar outside of that. For example, I wrote a paper titled Continued Fractions on the Heisenberg Group. This is not a complete sentence, it's just a noun phrase, but that's perfectly fine for a title. By the way, most papers in this talk will be from my own papers because I know what I was doing when I wrote them. Now, because you want your titles short and pithy, you should cut unnecessary words, but generally leave in articles such as a, an, and the, and conjunctions such as and or but. An example of cutting unnecessary words should be to avoid a proof of, because people generally know that you're proving something. That's why you wrote a paper, so you don't need to tell them a proof of something. Unless you're proving a big conjecture, in which case a proof of what's-her-name's conjecture is a perfectly fine title. By the way, starting a title with on or about can hint that your paper is concerned with the topic in the title in a more general sense. For example, I wrote a paper called On Multiplicative Functions with Bounded Partial Sums. The result of this paper doesn't actually concern multiplicative functions, but it's closely enough related that anyone who is interested in multiplicative functions would probably find this paper interesting. Let's move on to the central topic. Titles should make clear what area your central problem is in, even if they don't make the central problem itself clear. In this manner, titles just behave a lot like keywords. In fact, sometimes a title is just a bunch of keywords strung together, as in Diophantine properties of continued fractions on the Heisenberg group. Diophantine properties, continued fractions, Heisenberg group, that's all keywords. To reiterate, titles do not have to state what you did or how you did it, but they should at least hint towards it. If all the previous title had been was Diophantine properties of continued fractions, it wouldn't have indicated what I had done in this particular paper. By stating that I was looking at it on the Heisenberg group, I emphasized the unique aspect of my paper. A good rule of thumb to follow here is to avoid titles so general that they could apply to any paper in the area. Or maybe even better, if your title would work equally well as the title for any paper in your bibliography, it might be a bit too general. Now there's an additional concern here. In a paper with only one major theorem, the central topic of your paper is pretty clear. But in multi-theorem papers, you have some choice in the matter. You could focus on the single most important result, Or you could focus on the unifying theme which underlies all of the results. Now let's talk about interesting titles. You should focus on a title that is informative first. Extra energy spent trying to make it interesting is generally not time well spent. Humor is kind of a hard thing to pull off. It can be done, but remember, everyone's sense of humor is different. Alliteration, as in bunches of Besicovitch bundles, basically repeating the same first letter on each of the words, can sometimes come off as juvenile, so you've been warned. There are, however, other ways of driving interest. For example, you can drive interest by the juxtaposition of seemingly contradictory elements. I titled a paper, Absolutely Abnormal, Continued Fraction Normal Numbers. Here, abnormality and normality are seemingly contradictory. So how could a number be both abnormal and normal? Well, guess you have to read the paper to find out. Now let's move on to abstracts. Abstracts are condensed, one-paragraph descriptions of your paper, generally no more than 3 or 4 sentences long, although there is a bit of play here, especially if the sentences are short. Abstracts, unlike most titles, are written in full sentences. Abstracts, again, unlike titles, should state what you did, and if it is of interest, also state how you did it. A possible cutoff on the how is to ask whether someone working in this area would learn something new by reading about your methods. If so, talk about them in the abstract. Abstracts can make use of well-known notation or definitions, but should be sparing with notations or definitions new to the paper. You can be specific, but not nitty-gritty. Not every mathematician needs to fully understand your abstract, but they should be able to generally follow it and understand that what you have done is significant. Now, every abstract is different, but if you need a potential abstract outline, here's one that just generally works. Give one sentence describing a motivation for your paper, one sentence describing your main result, one sentence describing your methods, and then one sentence describing an interesting consequence of your result. Here's an example of mine from that absolutely abnormal continued fraction normal paper. In this short note, we give a proof, conditional on the generalized Riemann hypothesis, that there exist numbers x which are normal with respect to the continued fraction expansion, but not to any base b expansion. This partially answers a question of Bugeaud. Note that in this abstract I do not describe what normal means. It's just going to be too long, so don't bother. I don't speak much on the method of proof either, but I do say that it is conditional on the generalized Riemann hypothesis. This offers a clue as to one tool that I use in the proof, and it's sufficiently unusual in normal number proofs that it really does merit mention in the abstract. Finally, by tying this into a result of Bugeaud, I am able to connect my work to important questions asked by others. Finally, let's tackle introductions. I want to start with a line from Paul Halmosh from How to Write Mathematics. There is no recipe and what it is. There really is no recipe for writing an introduction. In fact, there's a lot of disagreement over what should go into an introduction. But let me just tell you what my general recipe is, because at least it's a good place to start. There are generally 2 main styles of writing introductions. One method is to write a very terse introduction, only a few paragraphs long. This I found is popular in a lot of older papers, and also papers at some high-tier journals. They aren't expecting a lot of explanation, they just want you to get straight to the proof. Another method is to write a long introduction that covers a lot of ground. This is my preferred method, and it's what I will describe in this talk. Most people who read your introduction won't read anything beyond it, so this is why I like writing a good long intro that will leave the reader feeling like they really understand what your paper is about. Now, I'd probably say that an introduction has about 3 main goals. It needs to state your results, give context for them, and give an overview of your paper. If the introduction is the very first section, I'd like my second section to be preliminaries. This is for the more complicated definitions, lemmas, results from other papers, and so forth. It's the introductory material that doesn't belong in the introduction. Now here's my rough outline for an introduction. Motivation and basic definitions, history, results, methods, follow-up, and outline. Yes, I know there's an outline in my outline. Let's go through these one at a time. First, motivation and basic definitions. This generally consists of about the first 1 to 3 paragraphs of some of my papers. In a broad sense, you are trying to answer the question of why is the problem under consideration important? Is there a long-standing conjecture or problem that motivates this topic? As you describe why these problems are important, you'll probably also need to include basic definitions. You should include all the definitions needed to understand the rest of the introduction. Complicated definitions can be referenced as showing up later, like maybe you want to talk about strongly normal numbers but don't want to define them in the introduction itself. So just say strongly normal numbers, see definition 2.4. But if you avoid full definitions, make sure the reader still has a feeling for what the terms mean. Otherwise, they'll just be completely lost whenever you use those definitions in your introduction. This, again, will really depend on what journal you're submitting to. Again, high-tier journals want you to cut to the chase and assume that the reader is familiar with these things. History. In the history section, you should state what other results have been published in this area. If possible, focus on a progression of increasingly powerful results that lead to yours. But make sure you draw a contrast between previous results and your own. A reader, especially a referee, needs to know what you did differently. Now, there's a tendency to want to name drop in the history section, and you can if it's relevant. Indeed, you should if it's relevant. Part of how we convince other mathematicians that our work is significant is by pointing to famous mathematicians who also thought it was significant. But don't go out of your way to find an obscure connection, because everyone will be able to tell that that's exactly what you're doing. Results. This is simple enough, just state your main results as theorems. Now, there is an exception to this. If a result is too long or too complicated, you may want to state it after the preliminaries, but give some inkling of it in the introduction, either in a more general statement or in the form of corollaries. I had to do this in my dissertation, where my main theorem is, no joke, several pages long. I tossed in some corollaries into the introduction, just so people had some idea what it would do. Methods. In a few lines to a few paragraphs, give an overview of how you proved your main theorems. If you made use of some well-known techniques, maybe a Tauberian theorem, or the circle method, or the saddle point method, feel free to state so here. There's no shame whatsoever in making use of well-used techniques, and it helps to ground the reader. It would seem unbelievable, not to mention overwhelming, if a paper built all of its work from scratch. But be sure again to emphasize what you did differently. Again, a referee report killer is giving the impression that you did the exact same thing as something else, that your paper is merely an insignificant improvement. Connect back to the history. Other papers faced problem X, which we solved by doing Y. This can be one of the most informative things an introduction can do. Some of your readers might be the very mathematicians who faced problem X, and they want to know how you dealt with it. So don't forget this. Follow-up. Give some idea of what can be done after your paper. Did your work inspire you to make a conjecture? Is there something you were unable to do, but if you could do it, it would lead to a stronger result? Is there a natural next thing to study? Now, I know some people don't want to do this because they're worried about getting sniped. If you know what you plan to do next, you can discuss things that will appear in a forthcoming paper. Now, I know some writers like to put this at the end of the paper, but again, I like having it in the introduction because more people are going to read the introduction than the end of the paper. Finally, the outline. At the end of your introduction, provide a one-paragraph outline of your paper. Say things like, in section 2, we will state the definitions we need. In section 3, we will prove lemma 1. This is not a necessity, but it can be helpful. Long papers often include a table of contents, so that readers can figure out where each part of the paper is. In a shorter paper, you typically don't have a table of contents, so just toss something in here like that, so that readers know what to expect in each part of your paper. Now, there's a lot more to talk about writing. I'm not going to be able to mention it all here, but I'll include some links down in the description to various things that other people have said about writing. And that's enough talking about writing for one day, because I'm out of tea. Until next time, bye.